talking about the regression, quadratic regression on the 1024 notes. Now we're looking at the 1025 page. Okay, the steps up here are listed. If you have a TI-84 calculator and you want to be able to do regression in that TI, those are your steps. We're not using a TI-84 in class, so I'm just going to mark through that. If you have one, of course, you are allowed to use it. You can use it. But the majority of us are just going to be using Desmos. Okay, so these are the same steps that are just listed on that other page where we are doing this quadratic regression. We add the table, put in the data, and then type this in to get the find out what A, B, and C are, and then we write our equation. Okay, so this one is talking about the trajectory of a baseball being hit. It says that the table at the right shows the horizontal distance in feet traveled by a baseball hit at various angles. The initial speed of the ball is constant. Okay, so the ball, the pitch, the speed of the pitch is the same for all of this data. It's just the angle at which the ball is struck that is your X value. That's what's changing and how that affects the distance the ball travels. So if we think about that rocket example, or here a baseball example, a lot of our quadratic regression models are going to be projectiles. Okay, projectile motion is quadratic. Okay, you've got objects that once they go up, they must come down, right? They follow this path. So we are going to, in this one, come up with our equation so that we can predict. Actually, this one doesn't ask us to predict any of them. Okay, it just says to come up with the regression data, or use the regression data to come up with the equation. Okay, so we don't even have to make a prediction for this one. So let's go ahead and get back in Desmos and clear out the stuff from the last problem. I'm going to add a new table, and I'm going to put in this data. So the angle of the ball being hit and the distance that it goes, the horizontal distance. All right, so I've got all my data. Now I'm going to type in y1 tilde ax1 squared plus bx1 plus c. Okay, so I get my A, B, and C. Oops, did not mean to have a highlighter there. Let me get my pen. Pen. All right, so I'm just jotting down what A, B, and C came out to when I did that quadratic regression model. Now, this particular question asks us to write this rounding coefficients to the nearest tenth, if necessary. So I'm going to round that A, B, and C to the nearest tenth. So A would just be 0.1. Okay, x squared plus B would be 11.7. And then C would be 12.8. Okay, so I rounded each of those to the nearest tenth. Is everybody okay with that? So we've got to be good with our rounding. We got to make sure that we've typed in that regression model accurately in Desmos. All right, well, that one was nice and straightforward. Let's look at example 2. Okay, so we've got another example here of selling widgets at different prices and what the profit comes out to. But this time, instead of giving us the data and having us come up with the regression model, they're giving us the regression equation. Okay, they're telling us this is what we've come up with. Okay, so here is the equation. You don't have to find it, but we want you to use it to answer these questions. Okay, so this one, I'm going to pull Desmos back up, and I'm going to type in that equation. I'm going to clear everything out. I'm going to type in the equation they give us. So negative 20x squared plus 150x minus 22. Okay, and so I've got a parabola over here on the graph. So I can look at the graph. The maximum's way up there above 250. Now I can create a table here as well to help me answer questions. The first question says, find the profit to the nearest dollar for a selling price of $6.50. Okay, so first of all, we have to remember what's X and what's Y. The profit is Y. So they're asking, what is Y when the selling price, X, is $6.50? So 2 ways, actually 3 ways that you could do this. Okay, if you already have the table here, the quickest way is just type in $6.50 for X. If you're given X and you want Y, the table's really your way to go. Okay, so that comes out to 108. So 108. And I used the table. I'm just going to put a little note of how I solved this. I used that table that I created in Desmos. Now the second question says, find the selling price, that's X. So this time it's, okay, well, why won't you let me write? Give me a sec. Save and close. Let me type in here now. Okay, so this time they're saying, what is the selling price that would result in a profit of 100? So now it's reversed. Instead of giving us X and asking for Y, they're giving us Y and asking for X. You cannot type 100 into your Y column and it won't work backward. So you can't use the table here. Okay, you could use the equation and type 100 in for Y, and then you would have to algebraically solve this. Okay, that would take a little bit of time. So the best way to solve these is with the graph. Okay, so they're telling you Y is 100. So I'm going to type that in. Y equals 100. And you'll notice it puts a line at Y equals 100 on your graph. Okay, so what I'm looking for is the X value when that happens. So I'm going to go find that intersection of that Y equals 100 line and my parabola. Okay, there's those 2 points. So it happens twice. Okay, so I am using the graph to answer this question. Okay, if you need to, I'm going to give a little sketch of it over here to the side. Okay, so we've got this graph of our parabola. Okay, we don't need exact numbers or anything, just the general idea. We've got a parabola, and then we have this line at y equals 100. What we are finding are these 2 points. Because remember, this is your selling price and y is your profit. So do y'all understand why we're looking for those 2 points? Said when the profit, when the y is up at 100, what is the x? So we find these 2 points. Okay, I found them, and we're talking money, so we're going to round to hundredths. So it's 6.57 and 93 cents, 0.93. So y'all understand with how we found those, how we used the graph to get those? And what about this last question? It says, which selling price will maximize profits? So what should I be looking for? What word stands out to you there? Maximize. So we should be looking for the maximum of this graph. And the maximum, remember, is the vertex here, up here. So we're looking for that maximum, that vertex. So it says we want to find the ordered pair of the vertex. So I'm going to come over here to my graph. You can zoom out, you can scroll, however you want to do it. Find that maximum. Come on. It's up here. There's the maximum. So I'm going to write that ordered pair. It is 3.75 to 59.25. So I found the maximum on my graph. So it says, what is the selling price? Is X or Y the selling price? X is the selling price. Y is the profit. So when Y is the highest, up here, that's your Y, that's your X. So the selling price of the item is $3.75. So that's what they should set it at to maximize their profits. If they set the price too low, they don't make as much money. If they set the price too high, they don't make as much money because people buy less. Does this make sense? So using the parabola to answer questions, to make predictions. So you can use the table, you can use the graph. And we used the graph for both 2 and 3. If you need to make a note that we used the graph here, you can add that there as well. All right, let's take a look at this last one. Okay, they give us the data for a rocket shot from a launcher. This is time in seconds, X, height in feet, Y. Okay, write the quadratic regression equation. So I do have to enter this data into my table in Desmos. So I'm going to clear everything that I have out. Got a new problem here. Adding the table. 0.2, 0.4, 7, 0.9, 1.4. 24, 47, 79, 98, and 143. So again, it's y1 tilde ax squared plus bx1 plus c. So I get that data and I come over here and I'm going to answer these questions. Oops. Here. Okay, so my regression model, it says to round all coefficients in the equation to the 10th place. So this would be negative 14.3x squared plus 121.9x. I'm going to go ahead and finish this video. Y'all come back tomorrow. We'll pull it back up. And then my C would be 0.4. Oops. Okay, so rounding everything to the 10th, that would be my equation. So I'm going to type that equation in here. I'm going to get rid of all this. So y equals negative 14.3 x squared plus 121.9x plus 0.4. Okay, so now the questions ask us to use this equation to find the maximum height to the nearest 10th. Again, maximum. You're looking for the height. So I can see on my graph over here that height, it happens at 4.3 seconds. The maximum height is 260.2. This is in feet. So we found the vertex on the graph to answer that. Hang on one sec, let me finish this recording. All right, and then for this last one, at what time to the nearest 10th would the rocket be located at a height of 180? So again, telling me the height, that's the y, and asking when that happens, at what time. So what is x? So what is x when y is 180? So this is where I would type in y equals 180. And then I'm looking, go to 180. Here it is on my graph. And I'm looking for the x value there. So there's two answers. It happens at one, and it says round to the nearest 10th. So 1.9 seconds. And it happens at 6.6 seconds. Right. That's the last one. Let me double check. Yes, that was it. Okay, so you're using your graph to make these predictions from the regression equation.